So chapter 1.5 is all about analyzing graphs of functions. Okay, in this chapter, we're going to be looking at a lot of different shapes of graphs and trying to determine different characteristics like domain, range, where the function is increasing, decreasing, constant, so on and so forth, finding zeros, things like that. So let's get started. As we've said, the graph of a function is a collection of ordered pairs x, f of x. Notice this is the exact same thing as x, y. We are simply using the function notation f of x. As is true with all relations, each ordered pair on the graph is going to be a solution to the equation. The graph of a function can be helpful in both determining domain and range of that function. Again, remember, the domain corresponds to all the x values on the graph, and the range corresponds to all of the y values on the graph. Let's look at some examples here. Use the graph of the function to determine its domain and range. Well, which x values does this graph cover? You might notice there are no endpoints on this graph. Okay, this implies that this graph, this function, is going to continue to move down and to the left. Well, if it continues to move to the left and continues to move to the left forever and ever, the farthest left point on this graph is going to be negative infinity. Notice that we can travel along the curve through all values of x, and what happens? It continues to move to the right. And this graph is going to continue to move to the right forever and ever and ever. Therefore, our domain in this case is going to be all values of x. There are no points on this graph where the function is undefined. To write our answer in interval notation, we have parentheses negative infinity, comma positive infinity. Now, the range. The range has to deal with all of the y values. Well, how far down does this graph go? Well, on both sides of this function here, the graph continues to go down and down and down forever. In other words, it's going to continue down to negative infinity. And how far up does the graph go? Well, the highest y value is at y equals 8, the vertex of this parabola. Therefore, our range is all values of y that are less than or equal to 8. In interval notation, this would be parentheses negative infinity, comma 8 with a bracket. Notice the bracket around the 8, implying that this 8, this endpoint of the range, is included. It actually hits 8. All right, let's look at another one here. Use the graph of the function to determine its domain and its range. Now, with the domain, one thing to look at, right here at x equals 2, okay, our graph continues to go up and up and up. Here the function is increasing, right? And this part of the function, as x approaches negative 2 from the right, is going to go down and down and down. Well, what do we have at x equals negative 2? Some of you guys might remember what this is called. It is called a vertical asymptote, okay? The graph is actually never going to have an x value of negative 2. Similarly, notice that as the graph goes to the left, the y values get closer and closer and closer to 1. As the graph goes to the right, the y values also get closer and closer and closer to 1. Here, we have a horizontal asymptote. So in terms of the domain, I cover all my values of x on this graph except for x equals negative 2. Therefore, my domain is going to be all values of x cannot equal negative 2. Using interval notation, we have parentheses negative infinity, comma negative 2 in union with negative 2, comma positive infinity. For our range, our y values, this graph covers all y values from negative infinity, keeps going down and down and down here, all the way up to positive 1. Notice that it doesn't actually ever reach 1. And then from 1 all the way up to positive infinity. All values of y except for y cannot equal 1. In interval notation, this would be negative infinity, comma 1 in union with 1, comma infinity. And one more example here. Use the graph of the function to determine its domain and its range. Well, what values of x do I go through here? Notice the farthest value to the left for x is going to be -3. And that -3 is included because we have a closed circle here. How far to the right does this graph go? Well, I cover all values of x until I get to +3. Notice that there is an open circle at x equals +3, which means that it is not included. All values of x greater than or equal to -3 and less than +3. In interval notation, this is bracket -3, comma 3 with a parentheses. All right, the range. The range tells us all the y values that we encompass. Well, what's the lowest y value? That's going to be 0, and it hits 0. 0 is included. And I hit all my y values all the way up until I get to 3. Now notice, does it actually hit y equals 3? Yes. So that must be included in our range as well. All values of y greater than or equal to 0 and less than or equal to 3. In interval notation, we have bracket 0, comma 3 with a bracket. There is finding our domain and range by looking at a graph.